Welcome to this question. Oh, that was squeaky from Laurel. Annoyingly, she hasn't told me which year and stuff, so here it is. All right. So I hope I get the right answer, but if I don't, hopefully you'll know where I went wrong. All right. So we've got some information here about the decomposition of group 2 nitrate. So the first thing we've got to know, and this is what we have to know, is the coefficients of the decompositions are 2, 2, 4, 1. Okay, so let's do a general equation. 2 of the nitrates decomposed to 2 of the oxides plus 4 nitrogen dioxides plus 1 water. You've got to know that before you go in. All right. So basically we've got this and we've got to figure out which one of these is. Now you can brute force it. All right, and that means going through each one and see until you get these numbers. But there is a much quicker way, and let me show you. First thing you've got to realise is here we started off with 2 grams of this, of the nitrate itself, and we ended up with 1.32 grams of gas. So these two gases together make up 1.32 grams. But that means that the oxide formed is 0.68 grams. So actually, we're not going to use this stuff anymore. We're just going to use the 0.68 grams of the oxide. Now, as you can see, 2 moles here, 2 give 2. So this is 1-to-1 relationship, isn't it? So let me get a different color. Let me get a nice green color. So therefore, the number of moles of this, 2, divided by the atomic mass of the group 2 metal, plus 2 nitrates, and 2 nitrates are 14, plus 3 times 12, sorry, 3 times 16 is 48. There. It's going to equal 0.68 divided by the atomic mass of the nitrate plus 16. All right, and these have to be the same because the number of moles of the nitrate must equal the number of moles of the oxide. So if we solve for AR, that's all we've got to do. Actually, I don't like green anymore. Let me pick a nice dark blue. So solve for this. I'm cross multiplying 2AR plus 32 is equal to 0.68 AR plus this is 62, so that's 124. So yeah, 2 times 62 is 124. So this is 0.68 times 124. Okay, rearrange my terms to get my ARs on the left. 0.68 ARs equals 0.68 times 124 minus 32. Let me move the paper up a tiny bit. Okay, so this gives me, obviously, 1.32 AR is equal to, let me use a calculator for this bit, it shouldn't be too hard. Where are we? So it's 0.68 times 124, which is 84.32. I'm going to take away 32 from that, I get 52.32. So this is 52.32. Divide both sides by 1.32. Yeah, that's right. Divide that by 1.32. And I get 39.6. All right, as my atomic mass. And the closest one to that is calcium, which has an atomic mass of 40. So I'm going to guess the answer is B here. All right, now, it looks like a lot of effort, doesn't it? But you know what? It's not so hard. Just use this method. As long as you know this. First of all, you've got to know about the balancing, don't you? But this is a very easy method. Now, you can change this from the decomposition of the nitrates, all right? And you can use the same thing with the decomposition of the carbonates. For example, that this will obviously change, won't it? It won't be this. This is specifically for nitrates, but you can work it out what it is for carbonates as well. Hope that makes sense, and let me post this now.